Power series. A power series is a series of the form summation at n go from 0 to infinity, c sub n times x to the n power, which is c sub 0 plus c sub 1x plus c sub 2x squared plus c sub 3x cubed plus so on, where x is a variable. C sub n's are the constants called the coefficient of the series. In general, the series of the form summation n go from 0 to infinity c sub n times the quantity x minus a to the n power, which is c sub 0 plus c sub 1 times x minus a plus c sub 2 times x minus a squared. This is called a power series in x minus a, or a power series centered at a, or power series about a. If all of the coefficients are 1, then the series above is the series x to the n, which is 1 plus x squared plus x cubed plus dot 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 plus x to the n power plus dot dot dot. We recognize that this is a geometric series with the ratio x and the initial value a. It converges if the absolute value of x is less than 1, and when it converges, the sum is 1 over 1 minus x. And so 1 over 1 minus x can be expressed as the series x to the n, which is 1 plus x squared plus dot dot dot. As long as the absolute value of x is less than 1, or negative 1 less than x less than 1, strictly. And so the function f of x equals 1 over 1 minus x can be represented as an infinite series. And if we want to evaluate f of 1 over 2, we can simply use the series with x equals 1 over 2. In general, if we want to evaluate f of a, we plug a into the series. But then we can't add infinitely many numbers. We would use the partial sums. This partial sum is a polynomial function. Note that this series represents the function 1 over 1 minus x as long as x is strictly between negative 1 and 1. To evaluate the function using this series for values near the center of the series, we would need only a few terms. But to evaluate the function for x near negative 1 and 1, but inside the interval negative 1 and 1, we would need to use more terms to be more accurate. This series is not valid for any of the x value that is outside of the interval negative 1 to 1.